Okay, let me start. Okay, good morning to all again. I'm sharing the screen now. Great, welcome back to our class, SSP class. Today we're going to have very important experiment. I'm going to show that, and also very important question also. Let me share that. Okay, it's all effect and probe four probe method. So last time we completed this electrical total current density, electrical conductivity of semiconductors. Today we are going to discuss the four probe method, four probe method uh, and resistivity measurement over. This is also over. Oh, this today actually, yeah, this one we are going to do today. So we already discussed the conductivity, resistivity, right? We already discussed the what is the resistivity, what is the conductivity, right? So this is over, and today we are going to discuss the especially resistivity or sheet resistance. How do we calculate the resistivity? How do we calculate the resistivity? So I hope, okay, let me start this. So make sure don't forget to fill the attendance details, guys. It's very important. You're gonna lose attending when you attend the class. Immediately should you should also complete the details, attendance details. So I'm gonna okay. So the question is here is resistivity. What is the resistivity? Resistivity. How do we measure the resistivity of the sheath? Suppose you have the sample beta. You have the sample of polymer, like polymer in the sense you have the polythene cover or the vegetable bag packing material or medicines. When you carry the medicines, you carry the bag. So I want to find the electrical conductivity of this that particular sheet, that particular plastic cover. Okay, so plastic cover you took it and you want to measure the conductivity. We cannot measure the conductivity directly, beta. Conductivity we cannot measure. How do we measure it, sir? We measure the resistivity. So if you measure the resistivity, it's inverse, it's reciprocal to the conductivity. So once you know the resistivity, you can calculate the conductivity. So any material, why we need to do, sir? Definitely beta, where for packing material, for packing up medicines, for doing lot of applications like in industrial application, nanotechnology, definitely you need to know the resistivity. As you all know that Saturday seminar or webinar, it was really wonderful, research technology that we have discussed that day. Hope you understand a little bit. I hope you want to be scientist like that, and hope you want to move to America, Europe to do a lot of research over there and come back to India and discuss here. I mean, give your services to the Indian government. I mean, Indian country. So here resistivity. So we have to find the resistivity in order to calculate the conductivity measurements. So we use this. There is a this is a simple setup. So electrical resistivity is uh, 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 1 by sigma, and sigma we already calculated before. I told you what is sigma. It's a word. What is a sigma? We learn it. Tell me. J, current density, right? Current density, J electrons, J holes, right? So when you multiply with N, you're gonna get mobility. So you're gonna get actually Q N mu N, Q P mu P. Okay? So here Qn mu n. Q is the charge, n is the density, number of charge carrier, mu n is the mobility. And here Q is the charge. Again, P is the whole charge. Here P is actually what? Holes, related to holes, and mu is the mobility. Okay, and this is the formula for sigma. This is the formula for sigma. Okay, so how do we calculate it? So you got this sigma value from here. Remember, guys, so you should remember the sigma formula. This, whenever someone asks you, sigma is equal to q and mu. But if you have a two types of charge carrier, one is n, the other one is p, you have to add both. You have to add both beta. Okay, so now the question is sheath resistance. Sheath resistance, how do we calculate the sheath resistance? Resistance is equal to what we know, that R is equal to rho L by A. This formula we discussed, right? Sushma, did you remember this? We discussed the relation between the resistivity and resistance. Did you remember that?
Yes, sir.
So what do you, so resistivity is equal to resistance equal to rho L by A. So here I am taking rho L is actually length of this sample. So this is a homogeneous sample we are taking now. We have to find the resistivity. So L is actually length of the sample. So W into T is the thickness. So we need to know the thickness of the sample, that is T. Width is this one. So you need to calculate. Suppose if I take the sample like this, so the sample is definitely cylindrical shape. It has a length, it has also thickness, it has also width. It is also width. So you have the length, width, thickness. So the formula is here, rho is the resistivity, L by width into thickness. Okay, then what I am trying to write here, I am writing here RS L by W. So why I am writing here, when L is equal to W, what happened? Length is equal, let's say length is equal to width. Length is equal to width. So these two cancel, right? So in this case, these two cancel, means what is there? Rho by T. Rho by T. Okay. Is it clear? When width of the sample must be, sample is square shape beta. Sample is square. In this case, width is equal to length, right? Is it clear, Sushma, Narsimha?
Yes, sir.
So length is equal to W. So when that is the case, R is equal to rho by T. Can I clear it, this one? Did you note down?
Yes, sir.
Please note down, please copy everything. I don't want to repeat again and again, okay? I'm taking a screenshot and write it in the notebook. I'm going to check everything better. Before practical exams, you should come with notes. If you don't come with notes, I don't write, I don't sign it, I don't allow you to write practical exams. So fast is fast, beta. I'm very strict. I'm also teach well. I mean, I try my best to teach you all well. That's right. Sorry, I'm getting cough. I don't know. Okay. Maybe I have to. I have to. Give me 1 second. I'm going to drink water. Anyway, right. So we use the famous method. This is a very, very, very research method that we are going to use for the measurement of the sheath resistance or sheath resistance. Okay, we're going to, it's also your responsibility to mute all. Every time whenever you hear sound, there is an option called, not all of you, only co-host can do. I gave the 2 people co-host. Whenever you hear the sound, just make it, mute, because this is going to publish in the YouTube. Everybody can hear the, that doesn't make sense. So I'm uploading every class into the YouTube. That is up. That is, viewed by entire world people. So that is the reason I'm not using Telugu much. Otherwise, I can use Telugu. Okay. So instead of teaching you only you, this also helps for the world people. Many people, millions of people, they can watch my videos. That is the reason. Okay, you can try level best with, catching me, but whenever it's compulsory, please ask me to stop and explain. I'll stop and explain again and again. So now we are in the time like to measure the sheath resistance. Sheath resistance. What is sheath resistance, sir? And it's measuring the conductivity beta. Instead of measuring conductivity, we are measuring the resistivity. We also know the relation between resistivity and resistance. So resistance equal to what we got formula? Rho by T, right? Rho by T for a square sample. For a square sample, we got it this one. And to measure these, what method we are going to use it? The famous method is called 4-point probe method. What method? 4-point, very important. We can design this in our lab. If you come to lab, we can do this experiment. It is easy. 4-point probe method. I mean, 2-point, we can make it. 4-point kind of little tough, but anyway, we can do it. So the most common method of the measuring wafer resistivity. Wafer, don't think wafer. Wafer is a kind of like a silicon vapor sample. It could be anything, any sample. But wafer resistivity is with 4-point probe. What is a probe meaning? Technique. Probing means tracking. Probing means tracking, like getting the data, electrical data, resistivity data. The most common, they will ask 4 marks question. The most common method of measuring the vapor resistivity is, what is the method? 4-point probe method. How do we do that? Measuring the current that follows for a given applied voltage. So we apply the voltage. This is a sample. We apply the voltage and measure the resistance, or we measure the current. We measure the current, right? So we apply the, like IV graph. You just increase the voltage and calculated the, current. So that using the 4 probe instead of two, using the 4 probe instead of 2 allow us to force current through the two outer probes, where there will be still be contact resistance and current spreading the problem, but we measure the voltage drop with two, right? With the help of two probes, what we use it? Two probes we use it. We apply the voltage drop with two probes, with two inner probes using the high impedance voltmeter. So problems with probe contact are thus eliminated in the voltage measurement, since no current flow through easily contact. So the question is here, I'm going to show this experiment, don't worry. Okay. If they ask you 4 marks, you simply can write it. It is a really the wonderful method to measure the electrical resistance of a sample. First point. Second point is, this is the most common method of measuring the wafer resistivity with the help of 4-point probe method. And third point is measuring the current flow a given applied voltage. We measure the current when while applying the voltage. We also use the 4 probe, 2 probes to measure the voltage drops, 2 other probes to measure the current. And this is a very wonderful method. to minimize the contact resistance. 4 points are over. Can I repeat it or is it okay? 4 points. Can I repeat 4 points or are you okay?
Okay, sir.
Sure? Can I ask you to repeat 4 points? Do you want to repeat it? Can I ask one of you to repeat 4 points or do I need to repeat? Now you
Once more you repeat, sir.
now I know that. Now you ask repeat. Because when I ask you, you don't repeat it. But I know that when I ask that question, you will ask that question to repeat. So 4-point probe method is a wonderful method to measure the sheath resistance. Okay. The second point is this is the most research method to measure the wafer resistivity. Okay. The third point is and two probes of this out of 4 probes, 2 probes can be used to measure the voltage drop with the 2 inner probes we measure the current drops, and this would help a lot to minimize the contact resistance. Okay, now I hope you understand. I hope you will repeat it. Can anyone repeat 4 points? Who wanna tell 4 points, please? Sushma, can you repeat 2 points? Can you tell 2 points?
Yes, sir.
Please.
This 4-point probe measurement method is used to wafer resistivity
Hmm.
with the 4-point probe. In the two probes are used to measure the voltage, and
Drop.
other 2 probes are used to measure the current.
Very good, very good. And this is a really wonderful research method to measure the sheath resistance, and this will
Yes.
also minimize the contact resistance. Okay?
Okay, sir.
Right, good. And I ask you, I'm going to ask next other people to repeat it. Anytime you should remember, I'm going to ask again, this will do repeat again. So, Shailaja, get ready to explain this after my explanation. Right. So what is the 4-point probe measurement? Here you can see that data. So 4-point probe method is, this is a sample. So this is the sample. You can also see this is also sample. Where you keep the sample here. And these are the 4 probes. So sample here, typically, you can see here, and 1, 2, 3, 4. 4 probes are arranged in line with equal spacing S. 4 probes are arranged in line with equal spacing. These are the same space. 2 probes are used to flow current through the sample. 2 other probes are used to sense the voltage drop. Right. The voltage drop due to the parasite resistance are negligible because very little current flow in and out of these probes. So this last point you don't need to, but this will actually help or minimize the contact resistance. So out of 4 probes are placed, basically they are connected, arranged in line with the equal space. The 2 probes are used to measure the current and 2 other probes are used to measure the voltage drop, and this is the formula for resistance, 4.532 V by I. Once you know the voltage current, you can measure the resistance of the sheet. Once you know the resistivity, you can also measure the resistivity. R is equal to rho by T. So if you know the T, rho is known, right? Rho is the specific resistivity of the material which is given. This is given for you, right? This is measured. So you can easily find T by with the help of this screw gauge. So we can know the T, we can know this, we can also measure the resistance. This is a wonderful method. I guess you have to draw this figure when they ask 4 marks. You just need to draw this diagram and write the formula, write 4 points. So then I'm all measure. This is wonderful method, very exciting to talk about today. This method, Hall effect measurement. What is the Hall coefficient? What is the Hall measurement? Very important question. So what is the actually Hall effect? Hall effect was actually discovered in 100 years ago. So very important. This was discovered in 100 years ago. One point is over. When Hall is a scientist, actually, when Hall was observed, transverse voltage across the conductor subjected to a magnetic field. So what we do that, you keep the sample in a magnetic field. You keep the sample in a magnetic field. You change the magnetic field and you measure the Hall coefficient. And the Hall effect was actually discovered 100 years back. And you observe that transverse voltage, this is a bit MSc jam. I also posted the MSc physics paper in the group. One of my student wrote it. He got, I think, 70 out of 100 marks in the MSc competitive exam. He also going to write the JAM IIT exam in the next month. Even if he get MSc seat in Usmania, he doesn't want to join it. He's my student. So I have been teaching him. So I want him to send America. His name is Hari Krishna. He's going to, he's in Babu Jagjivan Rao College now, completed final year, and he got very good marks in MSc in Usman University, and surely he can get the seat in Usman University, but I don't want him to be in Usman University. I want to send him IIT Madras. Okay, so if you do well, I will definitely encourage you to go for IITs, not like doing these small jobs, 10,000 jobs, worst jobs. I want my student all are very well settled down. So, right, Hall effect is the effect was actually measured by scientist Hall, and he observed the, what he measured in a Hall effect. Transverse voltage. What do you observe it? Transverse voltage. Sushma, what he observed in
The
this experiment? Transverse
transverse voltage,
voltage. What he applied to the experiment?
magnetic
Magnetic
field,
field. When he was discovered this?
100
100
years
years
ago.
back. What he placed here?
Conductor.
Conductor. Okay. And this is the technique is more powerful than a sheet resistance. So we have used the 4-point probe method, but this Hall effect measurement is the wonderful technique, better than the sheet resistance measurement. And to describe above, which was we have discussed just now, and it can be determined separately easily. The basic method is to illustrate it in the next slide. So the left part of the, we're going to discuss this later. Okay. And you should remember that this is also powerful technique than the sheath resistance. And this was discussed in 100 years. And here is sample is a conductor. And here they observe the transverse voltage. And the subject we apply the magnetic field. Can anyone repeat at least few points here? Shailaja, can you repeat what we are doing here? We are doing the Hall experiment. Hall. We have this lab also. Tell me one point. Hall was discovered. Shailaja, are you there? Swapna, are you there? You have to speak. Otherwise, I'm going to keep 0 marks for you. Shailaja, are you there? You're not there? Arshvardhan, can you repeat what 2 points at least from here? Hall was discovered 100 years back and he observed that transverse voltage when he apply the magnetic field. And this is a powerful technique than the sheath resistance. And you don't want, I know that you are just opening the, joining and keeping the phone there and going somewhere else. It's a very bad
No,
practice.
sir.
But you are not, why you are not telling? Tell me, Nana. I know that you're not, but you should speak it. If you don't speak, also I don't encourage that. My students should, improve their communication skills. My students should learn the physics like anything. All my students want to be world level scientists, not like constable job, not like a teacher jobs. I want them like they all die in the scientist. Until the end of the day, I want everyone should do the research. Then only our country develop. So everyone should, do the research, and everyone should become a scientist in any field, engineering, physics, chemistry, any field. But they want to do it. Last day of our life also we have to die with research, like Abdul Kalam did it. We have to do that. Right. So here, the point here, uh, this is a simple experiment, beta. Spreading of resistance of probe. So you can see here, this is a schematic experiment. Hall measurement, Hall coefficient measurement. You can see this is a sample is here, okay, and you can also see here schematic diagram of spreading resistance measurement, and we will sample. So sample is here, sample you can place it here, and you are keeping the probes here, connect to measure the voltage drop. Okay, so when you want to measure this is the probes to measure the sheath resistance. It's a wonderful experiment to see the Hall probe. Hall probe can help to measure the voltage when you apply the magnetic field. And I'm going to show now video of one of the, okay, where is, I want to do that. So can we watch four probe method?
Resistivity by four probe method.
Are you able to watch it? Are you able to see that?
Resistivity of a
Yes,
Yes,
sir.
sir.
Please.
at different temperatures. To plot the variation of resistivity with temperature. Apparatus. The experimental setup consists of probe arrangement, sample, oven measuring 0 to 200 degrees Celsius, constant current generator, oven power supply, and digital panel meter measuring voltage and current. This method is employed when the sample is in the form of a thin wafer, such as a thin semiconducting material
1
deposited
millimeter
on a
thickness.
substrate. In four probe arrangement, the four probes arranged linearly in a straight line at an equal distance, say 1 mm from each other.
Yes.
A high impedance source is used to supply the current through the outer two probes. A digital voltmeter measures the voltage across the inner two probes to determine the resistivity.
Correct.
An oven is provided with a heater to study the variation of resistivity of the sample at different temperatures.
Yes. You can see the different temperature, you can change it.
Theory.
Yeah.
Resistivity of the slice of semiconductor
Yes.
having thickness W is computed as rho is equal to rho 0 the whole divided by I into 2
Yeah.
pies, where
Yeah, you can
E is
see
the
this.
potential difference between inner probes in volts.
Right.
I is a current through the outer pair of probes in ampere. S is the spacing between the probes in meter.
Okay. Are you able to follow that?
Procedure. The sample is loaded carefully in the sample space provided. Is connecting it to the current source. The voltage developed across the middle two probes is measured using digital voltmeter. Probe arrangement is placed inside the oven, which is connected to the heater supply. The set button is used to fix the temperature in the oven. Once the temperature is set, use a run button to start heating the oven. Wait button is used to stop heating at a particular temperature, and measure button displays the present temperature in the oven. The resistivity of the sample can be calculated by the temperature of the oven. An oven is provided with a heater to study the variation of resistivity of the sample at different temperatures. To plot the variation of resistivity with temperature. Applications: remote sensing areas, resistance thermometers, induction hardening process, accurate geometric factor estimation, characterization of fuel cells by polar plates.
So did you find it? Did you observe anything here? Can anyone?
A supply and digital panel meter measuring voltage and current. This method is employed when the sample is
Hello,
performed
class. Busy in the class. Busy with the class.
thin semiconducting material deposited
Yeah, I'm busy
on
in the
substrate.
class. Please, I'll call you back.
In four
Yeah,
probe
thank you.
arrangement, The four probes arranged linearly in a straight line
Right.
at an equal distance, say 1 mm from each other. A high
See, observe carefully, guys.
supply the current.
So current they are applying the last two ends, observing the voltage middle ones.
Measures the voltage across the inner two probes.
So inner two probes can measure the voltage
An
drop.
oven is provided with a heater.
So one is provided to control the temperature.
At different temperatures. Theory. Resistivity of the slice of semiconductor.
You can measure any sample also. This is the we just did it. You know this one, right? Resistivity measurement.
Function of W by S. By knowing W by S, function of W by S can be found from the reported table, where rho 0 is equal to V by I into 2 pi S.
Yes.
Where V is a floating potential difference between inner probes in volts.
That's the resistance, you know that, right?
Through the outer pair of probes in ampere.
Let's say V by I is the resistance.
Between the probes in meter.
S is the spacing between the probes.
Procedure. The sample is loaded
So you can place any sample there.
Provided. Mount the four probes on the thin slice of the sample without damaging it. A constant current is passed through the outer probes, connecting it to the current source. The voltage developed across the middle two probes is measured using digital voltmeter. Probe arrangement is placed inside the oven, which is connected to the heater supply. The set button is used to fix the temperature in the oven. Once the temperature is set, use a run button to start heating the oven. Wait button is used to stop heating at a particular temperature, and measure button displays the present temperature in the oven.
Yes.
The resistivity of the sample can be calculated by the temperature of the oven. An oven is provided with a heater.
So this gives the resistivity is a function of temperature. At any temperature, you can see as you increase the temperature, resistivity increasing.
Applications.
And there are a lot of applications.
Remote sensing areas. Resistance thermometers. Induction hardening process. Accurate geometric factor estimation. Characterization of fuel cells by polar plates.
Any questions, students? Did you understand? Did you understand? Hello, students. Did you understand?
No, sir.
What? You didn't understand? That's a simple four-probe method, right?
When we say that we are learning public speaking,
So you can also see here Hall coefficient
we
experiment.
focus on these three areas in public speaking. For स्वागत है आपका मेरे YouTube चैनल पे। तो दोस्तों आज हम लोग परफॉर्म करने वाले हैं एक्सपेरिमेंट जो बेस्ड है
हॉल इफेक्ट कोएफिशिएंट सी।
शुरू करते हैं। तो दोस्तों अगर आपको नहीं पता हो कि होल्स इफेक्ट क्या होता है तो उसके लिए मैंने ऑलरेडी वीडियो बना दी है होल्स इफेक्ट से। तो आज मैं आपको
दिस इज हॉल इफेक्ट।
होल्स इफेक्ट से रिलेटेड एक्सपेरिमेंट। दोस्तों इस एक्सपेरिमेंट में हम होल्स वोल्टेज फाइंड आउट करेंगे। जैसे कि आप लोगों को पता ही है कि होल्स इफेक्ट क्या है, कि होल्स इफेक्ट
You have to apply the magnetic field and measure the Hall coefficient.
कंडक्टर को मैग्नेटिक फील्ड में रख देते हैं और मैग्नेटिक फील्ड में इस तरह से रखते हैं कि मैग्नेटिक फील्ड
So you can see here all this is all probe.
हो तो उस कंडक्टर
Can you able to see when I show the mouse?
वोल्टेज डेवलप हो जाती है जिसे हम बोलते हैं होल्स वोल्टेज।
Yes,
तो उसी होल
Yes,
वोल्टेज
sir.
यहाँ पे
and you can keep this probe to measure the voltage.
हमारे पास इस एक्सपेरिमेंट में जो एपरेटस होंगे पेपर वो आप लोग ध्यान से देख लीजिए। तो दोस्तों सबसे पहला एपरेटस जो है हमारे पास वो आता है इलेक्ट्रोमैग्नेट। अब क्योंकि
These are the magnetic, you provide the magnetic field.
मटेरियल को तो उसके लिए हमें एक इलेक्ट्रोमैग्नेट की जरूरत होगी। तो ये हमारा एक इलेक्ट्रोमैग्नेट है जिसमें हम सप्लाई देंगे इस एपरेटस के थ्रू। ये है हमारा पावर सप्लाई।
You are giving the power supply, ammeter, this is ammeter.
इलेक्ट्रोमैग्नेट को जैसे ही
When you apply the current, what happen? You have the magnetic field generation. The current apply చేయగానే మనకు magnetic field వస్తుంది ఎందుకంటే flow of charges కాబట్టి.
है हमारा कांस्टेंट करंट पावर सप्लाई फॉर द गिवन सेमीकंडक्टर के। हमारे सेमीकंडक्टर में हमें करंट भी फ्लो करवाना है तो उसके लिए ये डिवाइस है जो हमारे सेमीकंडक्टर में सप्लाई को भेजेगा। और हमारा सेमीकंडक्टर जो है बेसिकली वो ये है।
So this is a semiconductor.
आप लोग देख सकते हैं ध्यान से मेरे हाथ में, इसे बोला जाता है हॉल प्रोब।
Hall probe.
अब इस प्रोब में आप ध्यान से देख सकते हैं एक क्रिस्टल आपको नजर आ रहा होगा।
శాంపుల్ చూస్తున్నారా? అది శాంపుల్ అన్న.
आपको नजर आ
శాంపుల్ లాక్ చేశారు చూడు, మధ్యలో నాలుగింటి మధ్యలో ఉంది
सेमीकंडक्टर है।
Semiconductor.
ध्यान से देखो इस क्रिस्टल को। तो ये हमारा जो है वो सेमीकंडक्टर है। और फिर दोस्तों इसमें आपको मेटालिक कनेक्शंस नजर आ रहे होंगे कि
కనిపిస్తున్నాయి కదా నాలుగు శాంపుల్ మధ్యలోది.
दोस्तों यहाँ पे जो हम इसमें करंट फ्लो करवाएंगे वो इन दो मेटालिक कनेक्शंस के क्रॉस फ्लो करवाया जाएगा ऐसे।
Yes.
और इस पे जो हम मैग्नेटिक फील्ड अप्लाई करेंगे वो इस करंट की डायरेक्शन के परपेंडिकुलर होगी ऐसे। तो ऑटोमेटिकली इसमें एक और वोल्टेज डेवलप होगी और उस वोल्टेज को हम फाइंड आउट करेंगे इन दो कनेक्शन।
It's like a 4-probe method beta. So you apply the magnetic field with 2 probes and measure the voltage another 2 probes.
हाल वोल्टेज की जो रीडिंग है वो मिल जाएगी और यहाँ हमें रीडिंग मिलेगी कि हम कितना करंट जो है अंदर भेज रहे हैं सेमीकंडक्टर। उसके अलावा दोस्तों मैग्नेटिक फील्ड जो हम यहाँ पे जनरेट करेंगे इलेक्ट्रोमैग्नेट के अंदर, इस मैग्नेटिक फील्ड को
You can change the distance between them. Closer తీసుకురావచ్చు.
इंस्ट्रूमेंट का यूज करेंगे वो है हमारा गोस मीटर। तो यहाँ पे हम गोस मीटर का यूज करेंगे। गोस मीटर आपके सामने ये है हमारा डिजिटल फ्लक्स गोस मीटर। इसके थ्रू हम इस इलेक्ट्रोमैग्नेट के अंदर कितनी मैग्नेटिक फील्ड जनरेट हुई है उसकी वैल्यू को फाइंड आउट करेंगे। कैसे फाइंड आउट करते हैं ये भी आपको बता देते हैं। तो दोस्तों इस डिजिटल फ्लक्स या गोस मीटर के साथ हमें दी होती है ये, तो इसे बोला जाता है गोस स्टिक। तो इस गोस स्टिक के थ्रू हम मैग्नेटिक फील्ड फाइंड आउट करते हैं। बेसिकली इस गोस स्टिक को हम रखते हैं मैग्नेट्स के बीच में ऐसे। तो जब इसमें ऐसे रखते हैं तो हमें फिर यहाँ से इस रीडिंग से यहाँ से हमें रीडिंग मिल जाती है मैग्नेटिक फील्ड। तो इस गोस स्टिक हमें రీడింగ్ दे रही थी कि कितनी मैग्नेटिक फील्ड यहाँ पे अप्लाई।
సో ఆ స్టిక్ ఏం చేస్తుందంటే ఎంత మ్యాగ్నెటిక్ ఫీల్డ్ వస్తుందో చెప్తుంది. ఇట్ టెల్స్ హౌ మచ్ మ్యాగ్నెటిక్ ఫీల్డ్ ఇన్సైడ్. వెన్ యూ అప్లై ద కరెంట్ అవి ఆ చార్జెస్ దాని గుండా పోవడం వల్ల కరెంట్ వస్తుంది. కరెంట్ వల్ల మనకు మ్యాగ్నెటిక్ ఫీల్డ్ వస్తుంది. దీని ఎంత మ్యాగ్నెటిక్ ఫీల్డ్ జనరేట్ అయిందో చెప్తుంది. హౌ మచ్ మ్యాగ్నెటిక్ ఫీల్డ్ జనరేటెడ్ డ్యూ టు కరెంట్. అది అక్కడ చూడొచ్చు మనకు.
कैलिब्रेट करना पड़ेगा अपने एपरेटस को। तो अपने एपरेटस को कैलिब्रेट करने के लिए के लिए यहाँ हम यूज करेंगे इस बटन का। एक बटन हमें दिया है
0 here, set 0. So you should make it like a 0 that before doing the experiment.
को 0 पे सेट करेंगे। तो दोस्तों इस बटन से हमें जो है इसको 0 पे सेट करना है तो आप देख सकते हैं कि मैंने जो
Zero
है
now.
जीरो बटन का इस्तेमाल करके अपने डिवाइस को बिल्कुल कैलिब्रेट कर लिया है। अब जो रीडिंग आ रही है बिल्कुल
0.
0.000 आ रही है। मतलब जब हमारी जो गोस स्टिक है वो हवा में है, स्पेस में है, जहाँ कोई मैग्नेटिक फील्ड नहीं है, तो ये हमारी जो रीडिंग दे रहा है
Yes.
बिल्कुल एग्जैक्ट दे रहा है, 0 दे रहा है।
But when you place it between the poles of the magnet, it changes.
2K की तरफ दिया है, मतलब इस टाइम पे जो मैक्सिमम रीडिंग हमें मिलेगी वो 0 से 2000 गोस तक की रीडिंग हमें मिलेगी। तो हम
Gauss meter, actually he's saying that Gauss, but it's a Gauss meter, magnetic meter.
वो मेजर कर सकते हैं। तो मैग्नेटिक फील्ड वैल्यू कैसे हम मेजर करेंगे दोस्तों? तो जो ये हमें गोस स्टिक दी है, इस गोस स्टिक को हम इस तरह से स्टैंड में लगा लेंगे।
Yeah.
और इस गोस स्टिक को इलेक्ट्रोमैग्नेट्स के बीच में इस तरह से
You have to keep it between them.
इलेक्ट्रोमैग्नेट्स
But మధ్యలో పెట్టినప్పుడు you can ఇప్పుడు చూడండి see 163 Gauss.
165 किलो,
That's the magnetic field.
तो नियरली इतनी यहाँ पे मैग्नेटिक फील्ड है। तो दोस्तों अब मैं मैग्नेटिक फील्ड को बढ़ाऊंगा। कैसे बढ़ाऊंगा कि जो हमारी कांस्टेंट पावर सप्लाई थी इलेक्ट्रोमैग्नेट के लिए, यहाँ से मैं करंट दूंगा।
Current, you can increase the current ఇక్కడ. Current increase చేస్తే మనకి ఏమవుతుంది? Magnetic field increase అవుతుంది.
मैग्नेटिक फील्ड भी बढ़ेगी।
1 amps చేసాడు ఇప్పుడు current see
मैग्नेटिक फील्ड बढ़ चुकी है।
1 point something.
तो मैग्नेट है अब यहाँ पे जो है
Very
मैग्नेटिक
simple experiment.
बढ़ चुकी है करंट बढ़ाने से। तो ये मैग्नेटिक फील्ड की वैल्यू हम अपनी मर्जी से सेट कर लेंगे। सपोज मैं चाहता हूँ कि मैग्नेटिक फील्ड की वैल्यू 1000 गोस हो, तो मैं करंट की वैल्यू को कम ज्यादा करके इसे नियरली जो है 1000 गोस पे सेट
1000 Gauss approximately. Yeah, it's close, but
जो
yeah.
मैग्नेटिक फील्ड है मैंने 1k गोस मींस 1000 गोस यहाँ पे अब सेट कर ली है। तो इसका मतलब हमारा जो इलेक्ट्रोमैग्नेट्स हैं वो इस टाइप के कितनी मैग्नेटिक फील्ड जनरेट कर रहे हैं यहाँ पे
1000 Gauss.
तो नेक्स्ट स्टेप दोस्तों अब ये है कि
Probe, hall voltage have to measure it now.
अपनी जो हमारी होल प्रोब थी उसको रखना है। मतलब हमारा जो ये सेमीकंडक्टर क्रिस्टल है इसको हमें जो है मैग्नेटिक फील्ड में रखना है। तो चलिए अब इस सेमीकंडक्टर मटेरियल को हम रख देते हैं मैग्नेटिक फील्ड में। और मैग्नेटिक फील्ड में इस तरह से रखा जाएगा कि जो इस क्रिस्टल के अंदर जो करंट की डायरेक्शन होगी और जो मैग्नेटिक फील्ड की डायरेक्शन होगी वो एक दूसरे की होगी म्यूचुअली परपेंडिकुलर, जिससे इसमें डेवलप होगी हाल्स वोल्टेज। और उस वोल्टेज को भी हम वोल्टमीटर के थ्रू फाइंड आउट कर लेंगे। तो चलिए शुरू करते हैं। तो दोस्तों हमने अपना जो सिस्टम था जो जर्मेनियम का बना हुआ था जिसकी थिकनेस थी 0.69 मिलीमीटर, उसको अब रख दिया है हमने इलेक्ट्रोमैग्नेट्स के बीच में।
It's very simple. See, you are keeping the sample in the presence of magnetic field and measuring the Hall voltage. That's it. Experiment.
अब इस ऑन प्रोब के अंदर आप देख सकते हैं अभी मैंने करंट 0 भेजा
Zero.
हुआ है, तो उसके कोरिस्पोंडिंग जो होल वोल्टेज इसमें डेवलप हो रही है।
So now you apply the voltage. Now it's 0. Now he is applying the current. So when you apply the current,
कोरिस्पोंडिंग यहाँ पे भी होल वोल्टेज डेवलप हो जाती है। तो अब हमें ऑब्जर्वेशन टेबल में बस इतना ही करना है, हमें कितना हम करंट भेज रहे हैं उसके कोरिस्पोंडिंग कितनी हॉल वोल्टेज डेवलप हो रही है।
that's it. So you increase the current and measure the voltage. That is the Hall voltage of the sample.
हो रही है वो हमें नोट डाउन करेंगे। तो इस तरह से हमें जो है रीडिंग्स लेनी है इस एक्सपेरिमेंट।
That's it.
तो चलिए तो इस तरह से हमें परफॉर्म करना है दोस्तों ये एक्सपेरिमेंट। तो अब आपको बताता हूँ कि ऑब्जर्वेशन टेबल में हमें और क्या क्या करना है। ये था हमारा एक्सपेरिमेंट रिलेटेड टू हॉल्स इफेक्ट। तो दोस्तों जैसे मैंने आप लोगों को बताया आपने ऐसे ही इस एक्सपेरिमेंट को परफॉर्म करना है। आपने करंट के कोरिस्पोंडिंग जो हॉल्स वोल्टेज आएगी उनकी रीडिंग्स जो है वो नोट कर लेनी है। उसके बाद आपको ऑब्जर्वेशन टेबल में जब रीडिंग्स नोट कर लोगे तो वहां से इजीली आप निकाल सकते हो हॉल्स कोएफिशिएंट। हॉल्स कोएफिशिएंट निकालने का सिंपल सा फॉर्मूला होता है कि हॉल्स कोएफिशिएंट का फॉर्मूला होता है VH into Z upon IH। यहाँ पे VH हमारी होल वोल्टेज, Z है हमारी थिकनेस ऑफ द क्रिस्टल, I है करंट और H है हमारी अप्लाइड मैग्नेटिक फील्ड। दोस्तों अगर आपको ये वीडियो पसंद आई तो प्लीज
Right. So
like this video and do not forget to subscribe my YouTube channel. Jai Hind, Jai Bharat.
okay. Any doubts, students?
What does AI mean for business leaders and for business managers? How can it be converted into value and opportunity? My name is Abhinanda Sarkar, and I am the Academic Director for the AI for Leaders program
Okay. Okay, done. Almost over. So I don't want to. Students, any doubts? Can you hear me?
Yes, sir.
Sir, okay.
So what we have done, two experiment. We also have this this semester. I mean, at least theoretically, you should know that. I don't want to this. Right. Okay. So Hall coefficient, today we learn actually there are two, I mean, how do we measure the electrical conductivity, electrical resistivity of a sheet, of a sample, of a silicon vapor. The two method, one is electric four probe method that we have done. I mean, there are four probes are arranged in a four, probes which are having the equal space, and last two probes measure the, which helps to measure the flow, the current around the sample, and the current passes through the sample, and middle two probes can be used to measure the voltage across the 2 points, and by which it helps, we can measure the electrical conductivity or electrical resistivity, electrical resistance of that sample. And the other method is the Hall probe method, Hall effect. Hall effect is, what is Hall effect? Hall is just scientist, and he apply the magnetic field and measure the voltage, right? He apply the magnetic field and he measure the voltage across the sample. What he did, he just placed the sample in a, with a sample holder, and he checked the magnetic field. He created the magnetic field with the help of two magnets, and he apply the current and measure the Hall voltage. At different current, he measure the different voltage, and that gives the Hall voltage. Hall voltage can be measured only in the presence of magnetic field. Is it clear?
Yes, sir.
సో చెప్పండి. సో ఆల్మోస్ట్ చాప్టర్ అయిపోతుంది, ఇంకొక 2 క్లాసుల్లో చాప్టర్ ఇస్ అయిపోతుంది. ఎనీ డౌట్స్? అటెండెన్స్ పోస్ట్ చేశారా? డిడ్ యూ కంప్లీట్ అటెండెన్స్?
Yes, sir.
Yeah, I'm posting again now, but I can see only 19 members are there. I don't know why they left, but it's fine. Over with a passion and dedication, they can listen. But that's I don't want again, poor attendance. I have given enough time to you. So what is that? Namaste. Someone joined Chintu. Namaste. I'm not sure. Yeah. Anyway, again, join with your name next class, and tomorrow we'll complete this and begin the periodic potential, Crony Penny model. That will take 2 classes. Then I'm going to. Who is this Chintu? From Chintu, who is this name? Chintu. What is the name of this student, please? Hello, Chintu. I can see the Chintu name is here. Who is this person, please? Please tell your name. SPCHUNTU. Does anyone know that? Chintu? Chintu, we are not here to say chart. That's very bad of chart. We are to discuss the subject, please. I don't want to discuss this, Tinnawa, Chayada. That's what is it? What we're doing, man? It's a very serious effort we are doing here. Does anyone know this guy, Chuntu?
No, sir.
Who is this Chuntu? Is he from GDC? Ayatnagar, Ibrahimpatnam? Anybody knows that? Chintu,
No,
what
sir.
is his name? Narsimha?
Sir, we don't know, sir.
But that I don't want to. Charting here, the chat box is provided only for discussing a subject. Not like, hi sir, how are you sir? Those things are not important now. Okay, Nana. So thank you so much. Have a wonderful day. Even doubts, sir?